Well, thanks everybody for attending the first ever meetup that we're hosting here at Intuit. And Intuit's been on a couple different journeys recently that have implications for operations. One certainly is, as the company has come from kind of a desktop background, there's certainly quite a bit to learn about how you move those offerings into the online world in a successful way. And then recently, of course, we've been on kind of a big push to move from internal private hosting to public cloud. And so I'm sure all of you are aware of a lot of the challenges that have to do with that. But we're super interested in sort of learning from the community and sort of finding out what other folks are doing, the cool stuff that they're working on. We also want to share some of the stuff we think we're working on. We have a lot of unique challenges ourselves, particularly with the kinds of data that we have and the challenges that public cloud kind of provide for that. So again, not a lot of introduction here. Just wanted to make sure that you all felt welcome. We're super excited to have you here. We have a great speaker, Alfred here, who just spoke at AWS reInvent, and certainly looking forward to what he has to say, but just wanted to welcome you all here. Oh, and I guess I should say, I'm sorry, I didn't even say my name. I'm Brian Adams. I lead site reliability here for the small business group. So that's why I'm somehow up here introducing.
Yeah, I'm just gonna add you.
All right, so we're going to go ahead and get started. I think we pretty much have everybody who was standing in line who's coming in. If not, they'll be walking in shortly. But I'd like to go ahead and introduce Alfred Tan, who'll be talking to us today. And just for those who are here, we'll have some additional information about some opportunities that are closely related to some of your experience. All right, so with us, Alfred Tan.
All right, thank you. So, quick background about Intuit. We're the makers of QuickBooks, TurboTax, Mint. So we serve the consumer market, small business, accounting professionals with Intuit Lacert. So at Intuit, our mission is to actually simplify the business of life. So our mission here as part of Development Productivity is actually to simplify the life of our engineers, make it easier for them. So let's talk about some of our challenges in migrating to the AWS cloud. So at Intuit, we take every precaution to protect all of our systems and our data. We have strict security requirements that we must adhere to in order to host any application or service in AWS. We're also required to use threat modeling in our architecture design to ensure we build security in from the very beginning. Our next challenge is any new service that we create must be onboarded into CI/CD. With our all-in strategy and moving to the AWS cloud, we have huge volume of services that need to be migrated. Each of these services needs to have its own pipeline created. If we're going to do this manually, it's going to be time-consuming, resource-intensive, and error-prone. And finally, any of the service that we host must be highly available. So let's take a quick poll. Who has similar challenges in AWS in hosting their applications today? That's great. That's what we're here to talk about. So to solve these challenges, we actually created a tool called Slingshot. So what is Slingshot? Our creator of Slingshot is right there. So Slingshot is actually our internal tool that automates the hosting of our applications and services in AWS. So we built security in. This means actually using industry best practices, tools, and principles used in software development, in architecture, and also security, and building that into our software and into our infrastructure. Next, we automated the entire onboarding process into CI/CD. That's providing your build automation, your deployment automation, your server provisioning. So all you guys really need to do here is actually check in your code and your test. And finally, we built Hatter, or a high availability disaster recovery into Slingshot. So that just means that any of the services that we host is actually hosted in multiple availability zones, or AZs. So let's walk through how we do CI/CD at Intuit and how we actually build security into our software development pipeline. So let's start with the build phase. So as soon as you check in your code, we'll automatically build it and execute your unit test. Then we'll run your code coverage. This is to calculate how much of the code is actually being tested. Then we'll run your static code analysis tools like PMD and find bugs to ensure that we identify inefficient code. These are like your dead codes, your duplicate codes, empty try-catch blocks, and so on. And then we'll actually run check styles to ensure our code actually adheres to our coding standards. And finally, we'll run vulnerability scans with Fortify and Nexus Lifecycle to ensure our code meets the basic level of software security. So as part of our CI phase, we're mainly focusing on build and unit tests and providing quick feedback on the quality of the code flowing through our pipeline. So our promotional criteria during the build phase is just it has to build, it has to pass the unit test, and code coverage should be greater than 80%. When we meet that criteria, we'll automatically deploy that to your CI environment. So this is basically our dev environment. We're starting to call them in CI just because we're starting to extend what CI is within Intuit. That would include the deployments to this environment plus your integration tests here. So here we'll actually deploy your build artifacts and your configuration files, and then we'll run your basic acceptance tests, or your BATs. Your BATs is basically, all it does is to ensure that your code is good enough for QA. So when the BATs test pass, we'll automatically deploy that to your QA environment. Here we'll run your functional tests, your regression tests. In addition, we also run your dynamic application testing with AppScan. And then when your regression tests pass, we'll automatically promote this to your E2E, or end-to-end, and perf environment. We'll do this in parallel. So our promotional criteria here, it's basically it just need to pass the E2E. We execute your partner certification testing in your E2E environment, or your E2E test, and your performance test or load test in the performance environment. And then when that passes, we will deploy that to production, where we'll run a quick smoke test. And in addition, we'll run web app scanning with White Hat. So this is actually part of our continuous delivery and deployment pipeline. So as part of continuous delivery, we require our deployments to be all fully automated and consistent across all the environments. Promotions in the pre-prod environments are all automatic with triggered deployments into production. So the main difference between the continuous delivery and the deployment is that trigger into production, whether it's automatic or it's a manual trigger. That's the only difference. Our vision is actually continuous deployment, where there won't be any human intervention for the deployments, meaning that your deployments into production are all automatic and deployment approvals are all built in. So let's walk through how we do CI/CD and how we integrated that into Slingshot, and actually how we actually put security into Slingshot. So let's say if you have a service and we're going to host that using Slingshot. First, we require an AWS account. Our requirement is every single service that we host must have two accounts, one for pre-prod and one for production. In addition to having those accounts, it needs to be separate from other service accounts. The reason for that is so that if an account is ever compromised, we limit the blast radius of the affected account. So next, we'll actually create your VPC with your security groups and your public and private subnets. This is actually part of our AWS account setup. So we build on top of this automation, and then we'll actually automatically provision your GitHub repo. Here we'll actually provide your CloudFormation templates for your stack creation, your Chef cookbooks to set up your EC2 instances, and then your Jenkins workflow engine for your CI/CD pipeline. Next, we'll actually generate your CI/CD pipeline. We'll create that. Here we'll actually provide your automation with Maven, your build automation with Maven, your deployment automation with Chef. And then we'll also do the promotion, your test promotion using TestNG, and then your promotion itself using Jenkins jobs. So next, we'll create your KMS keys used for your encryption and your SSH keys for your EC2 instances. And then we'll create your S3 buckets. Next, we'll create your egress proxy for your outbound connections and your bastion host to connect to your EC2 instances. And finally, your Splunk forwarder. I'm going to go through more details into the stack in a bit. So this is actually part of our initial setup. And they're actually executed once per account. So let's see what we've actually built with the account setup and initial setup. So this is what you get. So you'll get multiple public subnets. You see your bastion hosts, your bastion subnets, your egress subnets, your ELB subnets. In addition, you get your private web app and database subnets. So as part of our security requirements, we're not allowed to have direct access to our EC2 instances, so we have to set up a bastion host. We also set up your egress proxy for your outbound connections. So in addition, we actually use Squid to actually log all the outbound traffic. And then all your web app and database logs, we actually forward to our Splunk forwarder. That's actually being forwarded to our central Splunk server, where they are scanned and monitored. So in addition, we actually build your S3 buckets for your artifacts and your secret assets and your KMS keys for your EBS volumes and your secrets as well here. So we build on top of this, right? So as soon as you check in your code into your GitHub repo or your repository, once we know there's a change, we'll automatically create your public-facing ELB and your private ELBs. And then we'll actually create your web and application auto-scaling groups and your EBS volumes. Currently, part of the web tier, we actually support Nginx. And in the app tier, we actually support Node.js and Tomcat. And if you have a database tier, we actually currently support RDS MySQL and RDS Oracle. And finally, we create your DNS for your service. So this is actually part of our CI/CD setup, and it's actually a recurring event as changes flow through our pipeline. So let's see how we actually do continuous delivery at Intuit and with blue-green deployment. Anybody doing CI/CD today in the cloud? Okay, just a few of you guys. What about CI/CD with blue-green? Good. So let's walk through how we do CI/CD with blue-green. So let's start with the initial setup, right? We talked about the pre-prod accounts and the prod account that's separate, having its own VPCs. Here you'll see your public ELB subnets and your private web and app subnets. Earlier, we talked about the CI/CD pipeline, right? So we saw that, hey, once you check in your code, we build it and it passes the build phase, we'll automatically deploy that into your CI environment. So here we'll actually create your Route 53, your public-facing ELB and your web auto-scaling group. And then in addition, we'll actually create your private ELB and your app auto-scaling group. We'll deploy your build artifacts and configuration files here. Do a quick smoke test and update Route 53 to point to this new stack. And then we will run your basic acceptance tests. When that passes, we do the same thing in the QA environment. We promote it to the QA environment, build the same exact stack. Do a quick smoke test, update Route 53, and then after that, do your regression tests. So we'll do this throughout your entire pre-prod pipelines, right, until we're ready to deploy this to prod. So when it's ready for prod, we'll do that manual trigger, create the same stack in production, do that quick smoke test, cut traffic, or update Route 53 since it's the first time, right? So now we're live in production. All right, so the next time there's a change that flows through your CI/CD pipeline, we will automatically create a new stack. Here we'll actually deploy the new build, your configuration files. Do a quick smoke test in that green stack, and then cut traffic over to the green stack and destroy the blue stack. At this point, this is where we run your batch tests. So at this point, CI is done. It's on the new stack. One of the issues that we have with the blue-green is there's actually overheads in actually creating these stacks. At this point, I think it takes about maybe 12 to 15 minutes for us to create one of these stacks. So development, our Scrum teams have came to us and say, you know what, that's taking way too long. I'm not going to wait for that long, right? So we actually added an option into our environments here so that we can turn off blue-green. So the only time the stack gets created is when the first change flows through the system and the second change flows through the system. Once you have your blue-green, we just switch between the two, deploying your build artifacts and your configuration files. But we're still required to actually restack whenever there's a change in an AMI as part of our security requirements. So when the batch test pass for the green stack, we'll actually automatically deploy that to the QA environment. Here we'll do the same thing. Quick smoke test, cut traffic to the green stack, destroy the blue stack, and then this is where we run our regression tests. As you guys have noticed, most of our testing within the blue-green model is mainly just a quick smoke test, and then promoting that within the environment, and then that's where the rest of the testing really happens. So today, the entire guts of our testing is still across the CI/CD pipeline. So when the green stack is actually complete and we're ready to actually deploy that into production, we do that manual trigger, create the identical stack in production, do a quick smoke test, cut traffic over to the green stack. So in production, we're actually using a weighted round robin for our Route 53. So this way we can distribute the loads between the blue and green stack. So let's say we actually are not happy with what's going on with the green stack. We want to roll back. We can quickly roll back to the blue stack and then destroy the green stack. So at this point, all we do is just wait for the next change to flow through the system to make it to the production environment. Let's go to the other scenario where, let's say we started cutting traffic into production and we started off with 0 and we moved on to 5% and everything looks good. We'll continue increasing the traffic into the green stack until we have 100% of the traffic going there. At this point, we'll ensure we drain all the connections in the blue stack and then destroy the blue stack. Which one? Yeah, it just depends on what's out there. So generally it's pretty quick because we've actually routed all the new traffic in there. It's only what's existing, and you just want to make sure it finishes up. Yeah, if you have long-running process, that takes a little bit longer, right? So. No, gradually. We have tools that does it, but then the main thing is we have the SRE team that manages it. So initially our thing was we want to try to automate that, but they wanted to be more comfortable where they can actually gradually increase it. So by default, initially we wanted to give them some traffic. They say, no, put it at 0, we'll increase it ourselves. So that's how we do it. Yeah, so this one, most of our blue-green right now doesn't include the database layer. Yeah. So we actually create them once, like the database, and then that's part of our right between the initial setup and the CI/CD. But we'll take more questions later. Let's just finish this up. All right? So at this point, we have the blue-green deployment working pretty well. We're pretty happy with it, right? So we've been stacking a lot of our services with this. And then QA came with another problem. Any QA engineers here? Good. All right. So the next problem is their automation tests were failing because of the unreliable or dependency servers were going down. So my initial reaction was, why can't we make the dependency server more highly available? But it turns out that some of these I don't have control of. It could be on a third-party dependency server. It's not everything that we're hosting with Slingshot. So when these tests are failing, then it actually breaks our pipeline because the builds are not being promoted. So our solution to this problem is actually to use Warmock. So let's walk this through. So let's say you have an automation test that will actually talk to your system under test, right? So, or your SUT. And then the SUT talks to your dependency server. So when the dependency server is not available, your automation test would fail. So all we did here was actually include, added warmock to be man in the middle. And then wire warmock to point to the dependency server, and the SUT to the warmock server. So let's run through the tests. So your automation test, the first thing it does is make a request to your warmock server. Let's say I have request A. And then within request A, you want it to stub it to return, let's say, a blue smiley face. So the next time the automation runs it through the SUT for request A, talks to the warmock. Warmock knows about that, will stub it, and then it will return your blue smiley face. So this will actually increase your integration test pass rate. Even when the dependency server is down, your automation tests still pass. In addition, we'll actually increase code coverage. Right? The nice thing about warmock is you can actually warmock, every single call that you want, or just the ones that you feel that you want to test. So at this point, let's say you have the same request A, and you want to go ahead and say, now that lets me return a blue sun instead of the blue smiley face. You can do that. Or you can create another stub for a different request. So at this point, the same thing. Automation test hits the SUT, talks to the warmock server. It knows about request B, returns your blue sun. So the nice thing about warmock too is, it doesn't really affect other teams calling SUT. So you can actually modify your request and put certain headers and say, I only want to stub tests that are with a header things that are my tests. So anybody else that doesn't have that same header, then it wouldn't stub those, right? And another thing is, let's say if you have a request C, for example, going through the automation test, you hit the SUT, talk to the warmock server. Warmock doesn't have that request. It doesn't know how to actually respond to that. So all it does is proxy it back to the dependency server. So what did we do with warmock? So with Slingshot, we talked about the dependency earlier today. And here's part of your initial setup and your SUT. So initially, all this did was actually point to the dependency server through your internet gateway. So with the issue that we were having with the QA team, all we did was actually create a brand new stack, your warmock stack. Here we create your Route 53, your public-facing ELB, and your warmock auto-scaling group. Then we actually route the traffic through warmock to get to your dependency server. So what are the benefits of using Slingshot? So first, you get early feedback of changes flowing through the system. So basically, you get that for free with CI/CD, right? With CI/CD, you increase the quality of the code flowing through the pipelines. With better quality, you get more frequent releases into prod. Okay? And finally, based on what we were trying to solve for our engineers to simplify their lives, we wanted to increase development productivity, right? So we can hire an engineer, assign them a task, and if they check in their code, there's a big possibility that their code will be flowing into production that same day. In addition, right, if you have a new service that you want to stand up, right, we will use Slingshot to automatically provision that service for you. So I'm going to go and invite Stephen up here to kind of walk through a video of Slingshot so you guys can see it in action.
Hello. So my name is Stephen Sang. I'm an engineer on the Slingshot team, and we'll be going through the onboarding process for Slingshot. So if you're a developer, we have a portal that you can log into. So this is our portal. You want to kickstart your new service. Slingshot. So we're part of SBG, so you pick your organization. Sorry about that. And then you describe your service. You put a little acronym. Describe your owner. And what happens after you click the button is the Slingshot onboarding is going to initiate. And you're going to get a GitHub repo. And so as Alfred mentioned, you're going to get CloudFormation templates, Chef cookbooks, Java starter code, and your pipeline, all in your repo. And we clone each of these for every service. So this is the initial setup that Alfred was talking about. We're setting up S3 buckets, the proxy, the bastion, everything you need to be secure. This is our secret bucket. We're using a KMS to do the encryption. And this is a view of our continuous delivery pipeline. If you look at the left, that's our build phase on the top row. And then in the second row, you're seeing the deployment to QA. In the third row, you're going to EDE and perf at the same time. So you'll see the flow, changes flowing through the system. And in a few seconds, you'll see perf failing. That's pretty much the continuous delivery pipeline that we have. And we're using the workflow plugin in Jenkins. We're also a big user of CloudFormation, and we use CloudFormation to spin up our stacks. You'll see that we're spinning up security groups and alarm actions. And we're also spinning up our auto-scaling groups. So we have separate auto-scaling groups for web and app. So you see the load balancers are getting created right now for build number 8. Now the app and auto-scaling group are getting created. Once that's done and we pass our smoke tests, the previous stack, which is 7, gets deleted automatically. Cool. Alfred will finish up.
Hello? Okay. So let's do a quick recap. So we talked about our challenges: strict security requirements, manual onboarding, and it has to be highly available. So our solution basically to these challenges is basically 3 things. First, we need to automate. Second, automate. And third, automate. And we automated building all the security requirements into Slingshot, automated onboarding into the CI/CD pipeline, and we built Hatter in. So here's our contact information if you'd like to talk to us a little bit more and share some of your stories and your journey into the AWS cloud. And definitely would like to kind of talk to you guys more about it. So any questions? Yeah, so we had a lot of pretty mature CI/CD pipeline that we've been using for payments quite a bit. So we've actually started integrating that into our AWS. So basically, anything that we have working on premise, we started, porting all that stuff over to AWS. It's actually integrated. So we're using Jenkins right now, but there's actually we might be changing some of that. So we're actually experimenting with code pipeline today.
A question about how often do you push your trigger your whole pipeline? Is that like a per day or per
As
commit?
changes flows through the system. So once you check in your code, remember we talked about the CI/CD. As soon as you check in your code, we run those tests. If it passes those tests, it'll automatically promote. The only manual trigger that we have is to production. So what we have is some kind of like a change request board where we talk about what's going to go inside production and what gets approved. We have the SRE team. All they do is just trigger those jobs.
So that means the final step, you can accumulate several commit and then push to the button.
Yeah. So they're all candidates, right? Because we don't have that automatic flow into production. So right now, we're actually looking at some of the APIs. We use ServiceNow to track our changes in production. So we're trying to talk to that API, and then one of our requirements is if we have any restriction periods and things like that, once I query it and I want to go create a ticket to deploy into prod, I should know about that. It gets rejected. So that's something that we're working on right now. That's still in progress.
Thank you.
Given Intuit is managing PII data for all the users, right, of its users, do you have a requirement to have EBS volumes encrypted? And if so, do you use AWS as encryption, or do you use local encryption where you maintain the key?
Okay. You want to handle that?
Yeah, so we use EBS encrypted volumes, and for our secret data, we actually have we encrypt into S3 using KMS with an in-house tool. And so we consume the secrets as well for using that same tool. But the volumes are encrypted.
Yeah, we have a tool called CLI Secrets that actually does all our secret encryption into that.
Yeah, it leverages KMS, but it's an in-house tool.
When you mean in-house, it actually runs in Intuit data center?
It's built by a team at Intuit, but we leverage KMS.
Yeah, it's running actually in AWS.
Oh, okay.
So Slingshot, what database underlying it's using? Because so when we are doing a complete automation of provisioning the account and then changing the CloudFormation template and executing the template, so every time you need to poll the AWS API, what is the status current? Then only you will be informing the project team, okay, your complete environment is ready.
We actually use Jenkins for that, so there's no database. So Jenkins is kind of the state manager at that point. So we use the workflow engine, and you saw the CI/CD pipeline. That's actually what is kind of holds our state.
Okay, so so the initial account creation of AWS, that time how the status you will be getting it?
So the initial setup just sets up your account, right? So as part of the pipeline hasn't created yet. There's no status, right? So basically, all of this is a series of steps that we do. So we set up your accounts, create your VPCs, and then we do the initial setup. That's when you get your GitHub repo. That's when you start getting some of your pipelines in there.
So basically, initial setup is manual work?
Yeah, it's actually, it's automated.
Okay.
So it'll kick all that stuff up, and all it does is get your account ready. So as soon as you check in your code, that's when all this pipeline starts happening. That's when so I think your question is mainly you want to find a state of what's going on in that thing. Jenkins actually tracks all our states.
Okay.
So I had a question about you guys were doing the weighted DNS.
Mm-hmm.
Why did you choose that instead of doing the just creating a separate auto scaling group? Is it because you could change the percentages, or had you?
Yeah, they wanted to do the percentage, and then we also do the Route 53 not only within AWS. Some of our data centers, we're also routing the traffic over there. So there are times that we want to say, hey, we want to test something new, or something's wrong with it, and we want to cut back. That's what we're using it for.
Okay, so for the most part, that seems like a better route than to create a different auto scaling group, I guess, in terms of trying to do a blue-green deployment.
Yeah, because basically we want to control the different versions of it, so we wanted to control it at the DNS level, right?
Okay.
Any other questions?
Yeah, so in production, when you're moving from blue to green, how you're managing the database under it? Because some customers might be connecting to the other database.
Yeah, so right now we're actually using blue-green mainly for the service itself, the web and app layer. So the database, again, our requirement is your database changes should be backwards compatible with the new code that you're doing. So that way we can revert back code. But right now we don't have blue-green running for database changes.
So is your database or RDS also encrypted? I mean, if you use RDS, I don't know what you use for the database.
So so we have a tool that we're rolling out that will encrypt like column level encryption, but it's up to the application teams right now to do that. And some applications do have PII data and they're required to do the encryption. But like Slingshot by itself doesn't support it. It's kind of the application teams that have to enable that support.
Okay.
How long does the whole transition, take place? Like 2 years, 1 year?
Oh, how long did it take us to implement this?
Right.
It's about, no, it's like more than that. Right? So it's about, close to 8 or 9 months, but we had lots of different working product already that we started integrating, right? It's not like it came from fresh from the start, right? It's not like we built everything from the ground up. We've already had tools like the CI/CD pipeline that we plugged into that, right? We have a lot of automation. So in-house, I was using Puppet quite a bit. So a lot of those things that we built, we kind of just translated to Chef and moved it out there.
And what the size the team of this project?
So initially, we actually had 4, right? Part of the core team, but we have also had some people that's actually helping to other Scrum teams to customize their Slingshot for their applications.
Thanks.
What type of compliance standards are you required to meet?
Yeah, for us, we meet a lot of stuff. So SOX, of course, like everybody else, right? So a lot of security requirements that we have. We are in payments, so we have to do PCI. So with PCI, they have strict requirements on a lot of stuff. What was that?
IDS, IPS, alerting, monitoring. Do you use HIDS?
Sorry, can you repeat the question?
What do you use for IDS and IPS? Yeah.
Yeah, intrusion detection. Well, we do some stuff with
so we have
and things like that, right?
some in-house tools that our cloud security team has built. And every time an account is created, like we use CloudTrail for monitoring. We use New Relic for application monitoring.
We use White Hat. We use AppScan. And also, we actually have in-house tools that actually check the grade. We grade our accounts. So every single account that's out there, we actually check for certain things, and we give it a score, like an F or A, B, and C. So
You can't do any scanning in AWS, right? Can you do that in VPC?
what was that?
In public EC2, you can't do any scanning.
No, this is our own tools within our own system, so that's why we have access to it. But certain things that are encrypted that you can't scan, yeah, I know, the security team has talked to us and say, we can't get into your accounts. We can't tell what's going on.
So I'm curious, how many servers, or like on order of magnitude, do you have in your production fleet, and how well do you think that the blue-green deployments are going to scale if you had many thousands of servers to deploy to?
So I think we actually have built Slingshot to scale to services, so the number of services that we can onboard. I think the biggest one that we have right now is probably in production is like 20 or 30, but we have like 20 or 30 services that are onboarded onto the system. I think we are going to switch to non-DNS flips for our blue-green deployments. One of the issues is not every DNS provider respects TTLs, so that's kind of an issue that we've seen. And but it can scale as big as you want with Amazon.
Yeah, the whole reason why it's going to scale is because each of these pipelines is actually just for that service.
Right, I understand. I mean, with my service, we do that too, but we were doing blue-green deployments, but we've kind of reached the the state where it takes too long to do our deployments because you're deploying to so many servers, and it requires a lot of resources to duplicate your entire fleet and replace it.
Yeah, so that's why we're looking at code deploy, because there's some advantages of code deploy when how you're actually deploying to the different fleets that you have out there. That's something that we're starting to look into.
Thank you. So for the legacy products, it's a different deployment strategy and the rollout strategy than blue and green. Otherwise, you're absolutely right. It's going to be very time consuming and resource consuming.
Right.
So I know you guys make AMI images. What part do you actually execute on the chef side in terms of that actually at building an environment that you actually run in terms of you just deploy code, or do you actually do more than that?
So the question is like what we use Chef for? Is that the question?
Yeah, I guess because if you use something like a microservice, you already have your code kind of deployed in the microservice. Where you could do that with the AMI image as well, or you can actually kind of do certain things after the image is up, and you can run your Chef recipes to maybe deploy code or enable services or whatnot.
So right now so at Intuit we have Intuit baseline. So they're kind of the baseline AMIs that we're authorized or certified to use, and we use the base AMI, and we pretty much do everything after that. Like I think we do some things in CloudFormation in the user data and CFN init. But it's basically just installing the Chef client and maybe setting up a repo, and then everything else is in Chef. Okay. It could be optimized though with a bakery type system, but we haven't gone there.
Because you guys were mentioning it took 12 to 15 minutes to bring up an environment. I wasn't sure because it's actually AWS side or on the Chef side. That's actually
that's mainly the auto scaling group. Whenever we actually build all that stuff, it takes a while.
Okay.
Yeah, and DNS takes about 3 minutes to flip for us.
And then the reason why, the nice thing about blue-green is because you create a brand new stack, right? I know it does take a while, but once it's ready, you just cut over, right? So.
And that's kind of why we're looking at code deploy too.
Excuse me. So these inbuilt tools, are you going to keep for yourself, or you are planning to sell to other
Yeah, so that's the same question that we had at reInvent. So part of the account setup at the very bottom that we talked about, that's actually being published in the public GitHub right now. So they released it at reInvent. So as part of the initial setup with Slingshot, we're still debating on what we're going to do. So that's something that we're looking into.
I remember you were saying the developers were complaining about the timing, but I see like in your early slide, like the first slide basically, for every check-in you're doing a basic test and also code coverage, which is 80% more. So how much time each check-in, it takes to have a successful promotion to check into the branch or trunk or wherever? And how many promotions on a day it takes basically?
Yeah, so a lot of the testing that we do at build and unit tests, our goal should be all within like 10 minutes, right? Build and unit tests all the time. So run code coverage. Some of the stuff that we do, like with the static code analysis and things like that, they actually run a later part of the day because we don't want to slow them down.
Oh, so that's morely like nightly or a timely?
Right.
Okay, just want to make sure.
And then usually, since we have development around the world, right, like in India as well, so we wait till the end of our day, then we kick it off, and then wait till the end of the day. So it's generally twice a day.
So the second developer must wait till the first promotion is successful?
No, everything just gets queued up, right? So the main thing is, each basically, if you look at it, every single check-in is a candidate to go out.
Right.
So basically, it'll run its own tests.
But if the first one fails, so
then the next one will pick it up because it's actually all integrated as part of your check-in. We grab everything, not just, hey, if somebody checked in our code that breaks and somebody else checked in on top of it, they all get pulled in.
And the dependencies are also handled, internal or external dependencies.
Yeah.
This question may be out of scope for this discussion, but Intuit must have had a big data center footprint, right? And AWS starting off is okay, but as you go with a lot of big instances, the cost of it becomes phenomenally high. So how is it in Intuit to use AWS from the ops cost perspective?
Yeah, so honestly, moving to AWS is not cheap, right? It's pretty expensive too, right? And then our requirement too is within our data center, we tend to kind of limit on how we're trying to build it because we're trying to save costs. With AWS, it's a little bit cheaper, so we're going all out. Say if cost is out the window, how are you going to build it? Just build it. Because we want to make sure that when we build it right the first time. Some of the major costs, I think with the EC2 instances and the compute, that's coming to be cheaper, but we tend to kind of still move things back and forth between the data centers, and that's where most of our cost is.
And I think the biggest thing that you get is developer productivity. So like within our data center, it can take weeks to get services out. With Slingshot, it takes like a day.
So do you leverage any high bandwidth connectivity between data center and AWS?
Yeah, there's some stuff that we're working with them to actually put direct connect. Brian, do you know where we're at with the direct connects at this time in the data center? I believe we have one in place right now, right? Yeah, we might have some direct connects in place right now. Okay. No, it's very AWS specific, right? So I mean, we're not using right scale or anything like that to make sure it's all cloud agnostic.
So we definitely use KMS, and that's kind of the key management service, and we use that for encryption. So that's one thing that we use. We use encrypted EBS volumes, so it's another thing that we use. There's a lot of services that we use. So we're pretty tightly coupled with AWS.
So I have a basic question. So the production deployments, they are scheduled or they are automated, or the check-in automatically promotes to production? So how they are handled?
So right now, we still have that twice a month, basically, to deploy into production. So we have a person that actually manages all the changes into production. So we can't push anything unless it gets approved. So that's what's holding us back right now with the continuous deployment. But just like what I said, we're starting to look at some interfaces with ServiceNow and build all that stuff in so that we don't need to go we don't need to go through this cab meeting anymore.
You mentioned you have 4 core team member in this particular DevOps initiative. Then I see in your demo you have multiple applications, right? How much involvement of those application team to get involved?
So the application team, a lot of their involvement is mainly because they try to change Slingshot to fit their applications. Like for instance, right, we might only support certain things out of the box, like Tomcat and Node. Some people want to use Mule, some people want to use Storm. So they start contributing based on that, and we try to make that into our base code and release it for everybody else. And that's how we're growing our automation.
And I have also a question about when you deploy blue and green deployment, yeah. So you doubled your infrastructure, right? So and one thing and another thing. And what about background services at that time? They will have doubled, load from both blue and green at the same time.
What do you mean the double load? Because we have auto-scaling group in each of the stack.
Yeah, but nevertheless, there is a background services. Yeah.
Oh, the batch services?
Yeah, so right now in our infrastructure, we don't support kind of batch services with the blue-green deployment. So they would have to be kind of manually deployed outside.
Okay, thank you.
And how are we, like in this Slingshot, how we are doing the monitoring of all the applications and web? Are you using Elk Stack or Splunk or?
So we use New Relic. So Chef installs the New Relic agent. And we automatically configure them like kind of based on the template parameters that we have.
So basically like in the part of your basic stack, New Relic agent and all the stuff will be deployed with that instance?
Yeah, the New Relic system agent and the Java agent because we're using Tomcat.
Okay.
Yeah, do you monitor between the pre-prod and prod or between blue and green? I mean, you do monitor, you mentioned about specific, but between the pre-prod and prod, is there any monitoring for any differences, or maybe is this kind of a hypothetical question first of all? Do you see, issues with those things where somebody has to manually check for, okay, what's gone wrong in prod versus when pre-prod was all okayed and running?
So there are some cases, but for the most part, we actually do this blue-green deployment. So we start everything from scratch. And so when you start everything from scratch, there's automation. I mean, sometimes you'll get an EBS volume that you can't provision. But if it's up, most likely, the services are up and running. So we don't manually log into boxes unless there's an issue.
Yeah, and then our monitoring is mainly within the environment, so not so much across the pipeline. Right.
And between those pipelines, you don't see many issues?
Yeah, because we built them all the same way. They all have the same monitoring, so if something's wrong within that application, then you get the same logs and you take a look at it. And our idea is if something gets tweaked underneath, because we also use Chef to kind of manage some of our config files, so if something gets checked, then we'll know that, if you don't go through the system, it gets reverted back.
Yeah, everything's checked in a GitHub. So if there's a change, it's probably either a commit or, there was an infrastructure API issue with EC2, then you just kind of terminate the instance.
Are we destroying our Bastion hosts right now after we're done?
No, the Bastions are part of the one-time setup.
But we don't destroy them when we're done, right?
No, we don't.
Okay.
We keep them around.
Okay. One other question, you mentioned DR. I didn't see, I can see HA over here, but not DR. Are you using the regions, the multiple Amazon regions?
So we don't have support for multi-regions right now. We're working on it. So our criteria for DR is actually multi-AZs. Because basically, even though when you talk to the Amazon guys, they say multi-AZ has DR.
Multiple what?
Availability zones, because basically they're hosted in 2 different data centers.
Okay. And do you verify that whether your environment is really in sync with the DR?
You get that with the AZs, right?
Yeah, because you're building it all from scratch, you're actually, every time you do a blue-green deployment, you're testing your DR strategy, because you're recovering from scratch every time. So you're practicing it weekly. Well, it's multi-AZ, and you're changing in both AZs, but so that's a HA strategy. That's not a DR strategy. A DR strategy is recovering from a disaster, and when you just run this Jenkins job and it builds it from scratch, that is what you would do in your worst case disaster recovery. And because it's all automatic and it's all there, you just build it from scratch.
One of the main goals of this agenda is also high availability. So how we can implement or how we can achieve this high availability, like if I want to deploy something onto production, I want to make it down. So even that downtime period, you guys can make sure that the other side is available. How does that can be achieved?
You understand that?
So I think the question is, how do we add DR to our current deployment model?
Yeah, like high availability, being like how the application will be available all the time for the customer.
So we are we already have auto scaling groups, and so we have New Relic. I'm not sure.
I think with high availability, as long as you have multi-AZ, right? So basically, if something goes down, you can kind of recover right away if you need to. And then all the other scenario that Anthony talked about was even in the worst case scenario, if everything is down, you can still build it from scratch. So we actually all have all that.
And we do have ELB health checks.
Yeah, multi-AZ, right? So that's the big, yeah. And then multi-region is the other thing, because if you look at AWS, they actually have region outages, right? So that's why we're looking into multi-regions. But again, there are certain things that runs in the US West that doesn't run in the US East and vice versa.
So this I guess his question is more like, how is HA achieved in the meaning, when we are doing a deployment, let's say production deployment, how do we make sure that there is no downtime?
How do you make sure what?
How do we make sure that there is no downtime?
So we have the parallel stack running, so that's how we make sure there's no downtime. So we have the blue stack, and then we're spinning up the green stack in parallel. So they're both running at the same time. Then we do the DNS split.
Yeah, you're not taking it down to deploy. You're building a brand new stack. Make sure everything's okay, then you cut over. Right?
Got it. Thanks.
Yeah, I have one question dealing with the PCI compliance. As you said, you guys are deploying PCI compliant microservice also. So how you guys are managing the access control and access audit? So as you said, you are deploying a Bastion server. That Bastion server has access to all the other servers. So that means in Bastion server, you have hard-coded the access control? which is common to all the other servers?
No, the Bastion host allows us to connect with the EC2 instances just for that account, right? So other companies actually destroy the Bastion host so that nobody has access to the EC2 instances.
No, but still, as a part of PCI compliance, you will be rotating the access control on the underlying host.
Yeah, so like your keys, your KMS keys and
Yes.
things like that, yeah, we're required to rotate that every so often, right? And then
So-
the same thing with the AMI, and you're supposed to patch your systems and things like that.
So for that purpose, you are using any tools, or just under AMI only you change the keys, SSH keys? I'm just talking about the SSH keys, not the
So we're
encryption
supposed
keys.
to, we have a job that will rotate our keys. So we also get notified from our security team when it's time to rotate our keys.
So how this thing impacts the Windows servers, which is part of ADFS?
Windows servers? Sorry, we don't.
Yeah, we don't.
Work Windows. Yeah, we have a little bit of small Windows footprint in-house, but in AWS mainly it's all
Linux.
Okay, great.
So I had a question about, all right, actually I lost my train of thought. Oh yeah, so on the, on your all scaling group, since you're dependent on Chef, you have to run, you run your Chef scripts after after your MI images come up. Isn't there a lot of latency when you need auto scale?
So so what we use is Chef Solo. So we put our Chef repo in S3, and we download that as part of our Bootstrap. So I mean, there's some latency, and we could optimize that, but yeah.
Yeah, there's definitely latency when you auto scale, because a lot of teams too say, hey, we have this certain trigger, and it takes a while to get that, right? So what they're trying to do is, can we scale earlier, lower than the threshold to do that?
Then that's not as cost effective then.
Yeah, exactly. And then with Intuit, we also have what you call RI, the reserved instances. So they always want us to kind of add +1 instead of using auto scaling group, because it's more expensive to just auto scale. Using the reserved instances are far cheaper.
Do you use any AWS?
So we got one last question, guys.
Thanks. Do you use any AWS services like SQS or, I mean, AWS provided services? And if you use, are they coming in the line of PCI level 4, PCI compliance?
So what we do is we partner with our cloud security team, and we work closely with them to see which services we can. So we have this whitelisting process, and we work with our cloud security team to vet the services and get them approved for production.
All right, thank you, guys.
All right, we have one more speaker with us. So I'll let him explain what he'll be talking about, but with us right now is Srinivas.
Yeah. So good evening. My name is Srinivas. I work at Yahoo. So I'm just here to talk about DevOps. I didn't know the target audience, so I put together a slide about how we do DevOps, how my group, what are the tools we use, what is the process. So just a raise of hands, how many are familiar, very familiar with DevOps, or new to how many are new to DevOps here? Just one person? Okay. Maybe a quarter, or so I was going to go through. We've been using DevOps, my team, for over a year now at Yahoo. So I wanted to go through how we transitioned from having a traditional operations process to DevOps, what benefits we have seen, and what tools we use. So if this is of interest, this will be a good conversation. Else, we'll have to make it more interesting by talking about. So this is where we started. I'm guessing most people who are into DevOps also started in this model, where you had two different groups, development and operations, working as silos. And basically the dev would say, hey, this is the build number that we have tested in QA, and you need to deploy it in production. And ops take that from your central repo and deploy it in production. And you run into problems, or if everything went fine, it would be a successful deployment, right? So the challenge there, as all of you know, is the amount of amount of information that's exchanged before the deployment goes. It's pretty much the build number and that we have tested, go ahead and deploy it in production. There is not much information that ops gets from development. So when we run into problems now, each team is blaming the other, telling that, hey, you didn't follow the right instructions, you didn't deploy it correctly, and the ops says, we had no instructions. We just told us to deploy and not make any changes, right? And not to, both the teams were, if you look at it, both the teams are doing exactly what the organization wants them to do. It's just that we are measuring teams with different scales. The dev teams are measured with, how many new features you can get into the production in this quarter or in your sprint. And ops is measured as what is your uptime? Like, is it 99.99%? Is that your uptime? And if you say that is your uptime, you did a great job. So when that goal trickles down from the executives to the teams, you can see that every single incident that happens in production, you look back and there is always a change that impacted that incident. So 100% of the time, then there's an incident in production, you could always trace it back to a change that was made in the environment that resulted in this issue, right? So now it almost looks like they have competing goals. It's like, to keep it up, you don't need to make changes, but if you don't make changes, you don't get the features into production. So what DevOps does, in my opinion, is to get both these goals together. How do we get both these goals? Because both these are working for the organization. How do we get these together? The basic idea is the only way you can get this is have both the teams talk more to each other. So what we did was, when we started this transition, we had two different teams, ops and dev. But the the operations team started participating in the sprint meeting. So they're part of the sprint team now. They are in the stand-ups. They understand what is the features that are being built as a part of that sprint, right? And every time there is a production issue, there is a dev on call who sits with the NOC and with the operations to look at the problem. So you're spreading the pain when there is a production issue. So the dev knows. Anytime you look at the log file and look at the messages, any dev engineer can instantly say which part of the code that message is coming from. Triaging the problem is much faster than what ops would do. Ops most probably goes and restarts the services and hope that it is going to work, right? And so that is where we started the transition. So basically, to get a successful migration into DevOps or transition into DevOps, the critical pieces that you need to have is, we spoke about the culture where there are two different teams, they need to merge into one team and have enough communication on a daily basis that dev understands everything. There is a time in the old process where dev didn't even know how many servers were running in production or what load balancers were being used, right? So they had no idea about the production environment because they had no access to production. On the flip side, ops wouldn't know anything what's inside the WAR file. They would know everything outside it, but nothing about what's inside the WAR file. So this is the barrier that we need to break. Another key point for success is the automation. And that, I think the previous speaker also touched on that. Automation is, when I talk about automation, I'm talking about how quickly can you build, how automated the build is, and how quickly you can build for the developers to test, right? That is one of the key. You need to keep the build fast, and it has to be self-testing. So unit testing is another point that was touched upon. So I will go through some of the processes that we follow within my group at Yahoo. What are the rules we put in place, and how that helped us minimize the number of problems we ran into in production. So this is the standard 4 pillars on which DevOps is measured, right? There's a cultural change that we spoke about between dev and ops. The automation is the tools, the developer tools that you need to put in place before you ask the development to take ownership for production deployment, right? That's the automation part, which your CI pipeline and your CD tools are going to give. Then you need to measure. This is another key area which helps in successful transition. Now, what do you measure? You measure every single piece in the pipeline. For example, if you had a dashboard for your dev team to say how many builds happen in a day, right? How many check-ins into master, how many commits went into master, how many builds were successful, how many builds were failed, how much of code review was done in a day. You could get all this information from Git. You just have to build a dashboard. So that's what we did. Every morning, a developer could go and look at a dashboard and see how many builds were done yesterday and how many of it failed. So that gives you pride in terms of how much work was done in a given day. It also gives the team an idea of where they are in terms of code quality, right? So this had a big impact in terms of teams taking ownership to the process and sticking to the rules in the process. And sharing, this is another key. This is sharing between the operations and dev teams. In Yahoo, Git is open. Anybody can look at anybody's code. Basically, you have to put a pull request for the team. You could write any patch, any code feature, and raise a pull request. The owner of that repository can review your code and merge it. So it's a pretty open culture, and that is what is enabling us to share and develop much faster. So that's the sharing part that is very critical. So culture and sharing are the two soft skills that an organization needs to embrace, and that normally comes top down. It's more of leadership that drive those kind of changes. Automation and measurement is easier to achieve. It's more tool driven. You need to put the right tools in place. You need to measure the right things and surface that information up front, and that will help the team take ownership, right? So that's what I wanted to highlight over here. Soft skills is the culture and the sharing. I wanted to say, what as engineers, as DevOps engineers, what could you do in this 4 pillars? You could take handle on automation and measurement, and these 2 key pillars can give an idea. Like every day, I get an email from Git to say that, hey, what are the different repositories my team owns, and how many of the repositories had code reviews before it was checked into master. So I can see 100% or 80% or 90% of the code that was reviewed. So, and then once I drill down into that dashboard, I can exactly see what was the code that was checked in without review and who checked in. So it gives information very easily accessible. It tells the team and the leadership team how the team is progressing with following the rules. So this helps in, we were at 40% code review in April, or when we initially started, right? Today, after 3 months, we are consistently at 100% code review. So this kind of information that surfaces every day helps the team move forward. I think people who are, you've been working on DevOps and using the CI pipeline, so this I'm sure all of you are going through this process on a daily basis. I wanted to share, what is the process that an application would go through, right? First, as a developer, you're sitting with the product owner. Every sprint team has a product owner, and the product owner and the developers plan on what is going into this sprint, right? Then, I'm sure it's the same across all companies. Every developer has a feature branch. Either a team uses a shared feature branch, or each one has their own feature branch where they develop and trigger a build. That build will, run your unit test, run your integration test, and then there is a testing environment where it will deploy automatically. So once it deploys, the product owner looks at that feature that they have built and basically tells that this is done. That's the definition of done, right? So he or she goes into Jira and says, hey, this is a particular story that's done. The sprint is completed. So once that story is done, the developer can raise a pull request into master. So we don't allow anybody to do a direct commit into master. It's always a pull request, and only a peer can do the pull request. So peer does a code review, and once the code review is done, the pull request into master. So another rule is, once the code is in master, it should always be deployable in production. So you can't have a build that goes out of master that cannot be deployed in production. It might not have all the features, but it always has to be a code that can be deployed in production. So you could have a version in production that's running. So anytime we deploy a version in production, we create a feature branch called prod release, so that if there is a P0 or a P1 bug that comes in, we fix it in the prod release and deploy it to production. But master is always going to be different from production. The moment the first story in sprint is completed, it's going to get committed into master. At that point, it's a different release from production, right? But you should always be able to take the build from master and deploy it in production. And it should work, the application should work. So that's one of the rules that we have. So at any given time, the master build should work in production. So how the CI pipeline works is at that time, once you're in master and you commit into master, that is when the production integration works. So it does a build from master, it runs all the unit tests, it deploys it into staging, runs your integration test, runs your load test, your security test, and then deploys it into production. So I heard somebody ask a question, how frequently you deploy in production and what is the method, right? We generally use 3 different ways to deploy in production, depending on the impact the application has and the scale of the application. So one is we use the CI/CD pipeline straight away. So every time you check into master, the build goes into production. So applications that are not very critical, not high, these are internal applications that we use for employees within Yahoo. So this goes through every day, multiple times it could be deployed in production. For some of the applications which are SOX related, which needs approval and a change management in place, so we have a 2 or 3 days a week scheduled deployment. So the build gets into master, but on a specific day at a specific time in Jenkins, the scheduler starts and deploys into production. The third one is when we have a manual intervention to production. This is which the sites are external facing, and we have millions of hits per day. That's when we do once a week deployment into production. And this is somebody going into Jenkins and hitting the button to deploy into production. So the person who's doing that, the ops or the dev person doing that, is not going to do a lot of checks before they do the deployment. They know whatever is in your repository in a stable branch is something that can go into production that's very well tested. And in production, this is the 4th, if you see the 3 lines, there's continuous integration, that is pretty much your Jenkins pipeline. Delivery is where you have your, Chef. In Yahoo, we use a proprietary tool. It's called Aria within Yahoo. We're trying to move out to Chef. There are a lot of teams that have moved to Chef. My team hasn't moved. We'll move in a quarter or so. So that's the delivery part. And the feedback, this is another critical piece where you monitor the log files for every single application that you run. So there are a whole bunch of tools. The next slide is talking about tools, where you constantly monitor your log files, right? And that is the feedback that goes back to the dev team. So one interesting thing we noticed was every time a dev resource was on call for a P0 issue, the very next sprint had a story to fix that particular bug. So if you didn't have the dev in your on-call, the ops is going to restart the server and maybe it's going to run for another 2 weeks and then run out of threads again and they're going to restart and nobody else will ever know the problem. It's just that the ops restarting the server. But when we had the dev look at it, they look at the log file, they know exactly which part of the code is causing this issue. They immediately go back and in Jira they add a story to say that, hey, this is the one that caused the defect. In the current build, we want to fix it. So the feedback loop is much faster in this process, and that has made we used to have about 2 or 3 P0 issues every month in earlier. When we did 100% CI/CD in Q1 of this year, between Q1 and now we had about 3 or 4 issues of P1. So we can see the code quality much better. Resolution is better and feedback is much better. So the benefits are definitely there. So this is another tool slide I put on what are the tools we use today in our CI pipeline, right? So I color coded with a specific purpose. I can talk about that as we go. So as you can see, it's like a periodic table of tools today for CI/CD, right? There's a lot of open source tools. Every day there's a new tool that comes out and tells, what particular small problem the tool is solving. And since it is open source, there is no procurement, there is no approvals, there's nothing. A developer can go download the tool and start using it. benefit from that too. So I just wanted to walk through this. In the previous slide, we did the logical flow of how the application lifecycle is. I wanted to go through on how this tool fit into that lifecycle, right? So first is Git. This is where a developer has the feature branch, starts developing, and once he thinks the story is he has fixed the problem in that story, he starts a build which will deploy into his testing environment, right? His dev environment. And what does he do for unit testing? We have a rule which says you need to have at least 80% code coverage for unit testing. So you have a whole bunch of tools that do this unit testing. You have PHP unit, you have Mocha, Selenium that does the functional testing. You have Jasmine, JUnit. Depending on the code stack that you're using, you could be using any of these unit testing tools. So once the unit testing is passed and the build is successful, that's when the product owner comes into picture and looks at the build, looks at the features, and goes to Jira and says that this particular build is done, right? So that's the next tool we saw here in Jira. So once the product owner gives the developer a go ahead, he raises a pull request. We use Git's code review. So basically, you could use Git, where you can have multiple each commit being reviewed. But if you have just GitHub's code review is pretty good for us, and so far it's worked very well. But there are a whole bunch of tools in code review that you can download and use it. So that is when you say you merge to master, and that's that. Sorry. Okay, the first is PHP unit, that's unit testing for PHP. Next is Mocha. Mocha is for Node.js, if you want to do unit testing in Node.js. Selenium is more of an integration testing with the WebDrive. Jasmine and JUnit for Java unit testing. So if you notice the first green here, the unit testing and functional testing. So that is the one that is testing, that is the one that is doing your functional testing of. Unit testing is you are mocking out all the external dependencies and testing just the unit of code, right? Functional testing is where we have identified what are the P0 and P1 processes in the application. And once you have, so a product owner is not going to test end to end of every single feature in the product, right? In that build, he or she is just going to test what is new and what she is interested in. But we need to make sure that if this build goes into production, there is no P0 instance created. I can give an example. One of the applications we support is Help. In Help, we want a user comes and looks at articles and doesn't find any problem, logs in case with Yahoo's customer care. So success is defined for this process if the case is created and it gets back an instance number. So the Selenium test, which does the integration testing, confirms that there is an incident number that's created. So if a user cannot create an incident in sales in our Help, that is a P0 issue, right? Where if he gets an error and he's not able to create an incident, the next thing they do is go to Twitter or Facebook and complain that Yahoo's help site is broken. So these are P0 issues that we cover. So that's why by the time the code is in master, your integration test, unit test, and code review is complete. There are a few more tests that happens further down, and that's when we can see before it goes into production. I'll go through that process now. Right. So once you commit into master, then the build starts. We have an artifact repo internally called dist. That's where we put, because the way we install is a slightly different way we install in production. So we push it to dist, and that is there you could classify it as a stable branch or a quarantine branch or a test branch. So once we build it and move it to the stable branch within our repo, it downloads that. That package gets deployed in our staging, and that's when we run load testing. So if you see here, the tools we use is JMeter. So JMeter has this cool feature where you could take the Apache access log and then feed it into the JMeter. So instead of running a load test on a static page, you could exactly mimic what the user did, right? You could have an access log of 1,000,000 users who came into your log file, who came into your site and clicked on various articles, and so all that is tracked in your Apache access log. You could JMeter can take that and play it as a load test. So we have some key parameters in the JMeter that says your response time has to be 40 milliseconds when we do the load of 40 requests per second. So if we achieve that numbers for every new build, that is when we say this can go into production. Right? Appium and this is Device Labs from Google. I don't know if you are in mobile app development. Appium is a really good open source testing framework. Google has Device Labs where you could actually run your tests on actual devices. They have hundreds of different devices that Android and iOS that you can run your tests on. Selenium runs your system test again, right? So after this, we have internally what's called the security test. So we have a tool that will go through your application and see if there are XSS vulnerabilities, right? It will try to pass on JavaScript in your URL and see how it handles. So that's a security test it has to pass. And once these tests are passed, the code goes into production. So what the greens that I've highlighted, what I wanted to enforce here is the key to success is testing, right? So all the greens that you see here is some form of the other. You're testing code, you're testing process, you're testing the application. And that's what happens repeatedly in your CI process. And that is the key to a successful implementation. So, I mean, I merged the load test and the security test into one block here, but you have at least 4 or 5 different times you're testing your code. And since this is automated, it gives you the flexibility of doing it multiple times and doing it right every time. And then once you go into production, so we have like A/B, we call A/B testing. I know a lot of people would have done A/B testing for your applications. A/B testing is generally done to get an idea about how users are using the new features. Like you could do a lot of instrumentation and then analyze the instrumentation to see if new features are being used by the users, right? But from an ops point of view, you could use A/B testing. When you say A/B testing, you're diverting 10% of the traffic to the new site. You could see the log files and see how the behavior is. What is the errors you're seeing in your log file? So you're impacting only 10% of the users at that time. So that is another way we look at analyze the log files when we are doing A/B testing. I don't know if anybody have used this Elasticsearch and Kibana for your log search. That's a very good tool as well. It's open source, and it can suck in your log file and give you a lot of patterns and dashboards on your log file. So that's a very nice tool. So that's the monitoring piece, and then we have the on-off feature switch, right? Feature flags is a key component or key software architecture style, I would say, where you would be able to enable or disable features. So when there's a major feature that's going in, we always deploy it in an off mode. We know the application is stable and existing features are working fine. Then we can switch on the feature anytime we want. So feature flags is a very key style that all developers should adopt. That gives you a lot of flexibility without any code change of bypassing large sections of code if you don't want to if you want to test it and release it in phases or release it at a later point of time. So that's the flag that I had at the bottom there. Selenium is again, that's for smoke test. Once you deploy in production, you do a quick smoke test to see that you're not breaking any critical process. So that's another test that you do. So if you see, there are 4 or 5 different types of tests that are automated in the entire CI/CD process. Nagios. Nagios is a monitoring tool. It's an open source monitoring tool. So it's what we do is you could do log file sniffing. So you could give a pattern and see say if you are monitoring for full GCs in your Tomcat, right? If you say I have more than 4 full GCs in a minute, then page my on call, right? So you could do pattern matching. If you see 500 errors, a lot of the applications we support are portals. So people could get 404 and they say screw it and go to another some other equivalent port. Like if sports was down, they would go to some other sports site. But we need to know how many 404s are happening in a given day. If it's continuously happening in a second, then page the on-call. So these are the key things Nagios allows us to do. So URL monitoring, SSL certificate monitoring. However complicated systems are, I have seen simple things like not renewing SSL certificate happens very often. So expiry of SSL certificate in a payment gateway. I read a news last year, right? It's a payment gateway and then the SSL certificate is expired. So a lot of things like that happen. So these Nagio and monitoring tools helps us keep track of those little things. ELK, it's Elastic, Logstash, and Kibana. It's a combination of 3 open source tools. One is a search, Elasticsearch, and Logstash is the one that can analyze your log files, and Kibana is a dashboard that you can build out of the analysis. So just search for ELK. It is, yeah. Yeah. Okay. That's awesome.
Are you using any messaging queue for ELK like Redis or Kafka or something?
So we use Redis for caching in all our applications. We just moved to Redis about a couple of quarters ago. We were using Memcache a lot, but we ran into issues when the cache was flushed.
So like how, what's the quantum size of logs like, and how Redis is performing?
We've been, like I said, we moved to Redis about 2 quarters ago. I mean, since it has this master-slave architecture, for us, cache refresh was a big challenge we were having. But since we have master-slave, we could put slaves in multiple data centers, and the performance compared to Memcache has been very, very good so far. I think this slide is overridden by the whole speech the previous talker did. So the slide was, we use Salesforce for our sales and service cloud. And this slide was to say, even if you had a SaaS or AWS or a platform as a service, you could use your existing CI pipeline to achieve that end goal. So we use the existing CI pipeline even to deploy in our Salesforce installs. We use Salesforce platforms for some of the applications. And we use the Service Cloud for our CRM and Sales Cloud. But we use the same CI pipeline to deploy change sets into Salesforce. So that was my last slide. Any questions?
Questions?
Okay. I think you're talking about this slide, right?
My question was, since you said you are using Chef, have you considered Puppet also, and what made to decide use Chef?
Actually, I forgot to mention that point. We don't use Chef also. We use a proprietary tool inside for our continuous deployment. We are migrating into Chef. No, we did not look at Puppet at all. We just a lot of groups within Yahoo are already using Chef, and that was a big because a lot of the cookbooks for the base servers are already there, and we just want to leverage them and build recipes only for applications that we manage. But today we use a proprietary CD because there's a lot of little tools inside Yahoo which is built over the years, like roles and other stuff where you can put servers and identify roles for the servers. So since these tools were already there, it was easy to tie them together with a custom tool and deploy.
So my question is regarding your second slide when you talk about DevOps exactly. So what's your view exactly on DevOps? Whether developer can handle the operation job or operation team can go to a developer role?
The answer to that is a longer answer rather than yes or no. The dev, the issues that we saw, we have when we have the operations, purely doing the operations work, and purely doing the dev is, there is no connection between the two, even though the code is same, right? So since this, if you tell the developer to do what the ops guy was doing before the CI pipeline was built, he can't do it, right? But this CI pipeline, the automated way of deploying code, is what is enabling people to do that deployment, right? That is the key. Now, what does the ops do in this is, operations will eventually, in my opinion, move to other broader areas like infrastructure management, security, high availability, DR. These are the areas where operations will focus on, rather than the day-to-day. And these, like Chef and Puppet, right? Their main theme is infrastructure as code. So that is what operations would be doing. It would be like today, if you want a box with 4 gig and 8 CPU with Red Hat Linux 6 or 7, you would have pulled a server, stacked it in a data center, and install OS. What the ops guy will be doing is actually writing a recipe to do that.
So is I can say that like infrastructure as a code will be termed as a DevOps team.
Infrastructure as a code is one of the pieces of DevOps. The CI pipeline is the main piece, is the second piece that is critical in DevOps.
No, still in CI pipeline, developer is not playing any role.
See, the success of, I cannot get into this. Oh, okay, it's there. So if you see, if this pipeline has to be successful, the key component, apart from the tools, the installing, getting your Jenkins up and running, getting your Git hooked to Jenkins, all that is a one-time task, right? The key piece is the green boxes, which is how much of unit testing, integration testing you're doing it, and that is where the developer's key role is. Getting the test coverage and having building the trust in this pipeline that the code that is coming out of the pipeline is deployable in production and is something that everybody can trust. So once you lose trust in the pipeline, if you deploy a couple of times and then you run into issues in production, the first thing the ops is going to do is, let me do a manual install this time, you fix the pipeline after that, and then let us use the pipeline for the next deploy, and that is when it's going to break. After that, it's never going to work again. So it is very critical that both the dev and the ops are involved in getting this pipeline working and trusted. Yeah, right. It's not a tool, it's a concept.
Hi. I had a question regarding the Nagios monitoring. You'll be having kind of servers which you build out from like scratch, right? And you'll be having a checks for that. So are you guys having only the web checks for it, or you'll be having the hardware checks as well?
It's both.
It's both, right? So the DevOps team will be considering, like, as he said, as an operations as well as a developer. So developer will be only involved in the code part of it, the deployment and the release, the operations will be involved in it. And then if there is some bug involved in that, a developer will come in and fix it. Just correct me if I'm going wrong somewhere. So in a DevOps team, you'll be requiring kind of 60% operations and 40% developer. Is it? I can say something like that. I don't know how you collaborate or something as a team. It will be operations like of 60%, and since we require more of a testing, and operations guys will be helping you more in that phase, right?
So the testing part is automated. There's nobody
Yeah.
specifically doing the testing, right?
So Jenkins will be helping you in that case, right?
So I didn't get your 40%, 60%.
Yeah, I'm like, if you're building a new team, say you're getting a 60% ops guys and 40% developers who is writing code for you, and the operations guy will be only writing the release, like building scripts and all those stuff for you.
So I haven't seen a place where there are more ops guys than developers. So there might be, your 40% developers, 60% ops seems to be a little bit off for me.
No, I'm just asking, like how.
I think we can talk about responsibilities. The developer owns everything end to end. right? The code deployed in production, quality of code. What the ops owns is the infrastructure,
That's like
the
after-
security. Huh?
Yeah, that's like in the middle of production and after the production, is it?
All the infrastructure, right from your dev instance to your test instance to your staging to production.
Okay.
So we are no longer talking about servers, right? When you go to AWS or to a private cloud, you're no longer talking about servers. You're talking about either containers or you're talking about VMs. So the ops person is no longer interested in if the server is down or do I have to maintain the server. They are looking at the platform, right? So that is how infrastructure is going to fundamentally change. It's not going to be about servers, and I don't think it's going to be about VMs either, because there's a lot of tech debt with individual boxes. You have an OS upgrade, you have so many components that over a period of time you're going to have versions that's going to change. So the way I look at it and the way my team is going is we have a container that can be destroyed and recreated with a new version every time. So that way you don't run into this tech debt of having a server that's run for a year with very old version of Apache or old version of Tomcat, and suddenly you have to upgrade your JDK, you have to upgrade your Tomcat, and that immediately is a tech debt that you need to work on.
Yeah, my question is exactly related to the infrastructure. So how do you, is there an orchestration layer over here? The way we were talking earlier about the slingshot that Intuit uses, do you have a layer above this which is really managing this whole end-to-end from a process point of view and also from an infrastructure point of view? How do you really tie it down?
So infrastructure is handled by Chef today at Yahoo, and the proprietary CD tool that I was talking about, we call it ARIA. So that is how infrastructure is handled. So the way we do it is, suppose we have an package to be built, we have this ARIA tool that will go and create your server in OpenStack. It will make your DNS entries. It will create your accounts. All that is done at the time of provisioning, right? So we have a central repository, central monitoring where all the users who are whitelisted are already part of that central tool called CM3, and that will go and create your accounts. So we can no longer log into production or any server and create a user, because within a minute or so it gets overridden. So you can't create an individual account in any of the servers. So that is where the infrastructure management comes, right? After that, we could run the CI pipeline on top of it and deploy your entire tech stack that you need for your application. So does that answer your question?
I think to a large extent. I was also wondering, right, if you look from an overall management stack point of view, right? I think that's Chef would be fulfilling a part of that management stack. So you brought in picture the open stack, but there are other pieces to it from an operations management point of view that are typically utilized. So I was trying to get a sense of what all are the various pieces over there, but I can understand that's slightly out of context over here. But one question I wanted to quickly check with you on, do you see a need for, from a production release point of view, I see that you're doing the monitoring and all that with Elk and so on, but to really have an visibility into your full service, service dependencies and having a system of record essentially of all of your, whether your microservices or full dependency of right from this higher level service access point to the infrastructure or even below that, because they may be all dependent in terms of like whether how your application performance is and all that stuff. So is something like that in use where especially for troubleshooting and all that you need to see that, or even from change management point of view you need to really keep track of all of these dependencies, or at least have the visibility into
so if you're talking about dependency in terms of packages, individual packages being compatible to each other, how we do it is there is when Jenkins triggers the build deployment, there is a list of packages that is there. Say I want to run a Tomcat application, right, and I am fronting it with an Apache.
that will be a build dependency. I wasn't
No,
talking about that.
yeah.
I was talking about runtime dependencies.
I mean, at the time of every deploy, it's going to check everything in the stack to see if it is if the versions are in sync with what is required for the build. But after it is deployed, you're saying is there a constant check to see if there is a compatibility? No, I don't think so.
So you mentioned about the ELK, right? Elastic, Logstash, and Kibana. So did you guys integrate all those three tools, or it was already integrated?
There's just one tar file you download, and it's all three in it.
So it's already available.
Yeah, it's already available. It's not even a container. It's just a tar file. You can just unzip it in your server. It used to be.
That was in the earlier, right? But these days, I think it is available as a single package. Yeah, a couple of weeks ago.
These three are separate tools that have independent purpose, right? You could use Elasticsearch anywhere you need a search index. But this particular log monitoring, I think one of the companies has released this tar file with all three. You can download that and do a quick POC.
So basically, you guys are using it for like as a Splunk, right?
Yeah, it's like
for like
Splunk,
log searching. It has like a user interface, meaning it has a dashboard kind of stuff.
Yeah, the
like
Kibana is the dashboard. The K is the dashboard.
The K is the dashboard. Okay, great. Thanks.
So basically, I wanted to ask you. You mentioned about coordination of having the developers and ops coming closer. A quick question is: does your development team or developers do builds to production?
Do deploy into production?
Yeah.
Yeah.
And then are they on call?
Yeah.
Okay.
So if there is an incident, there is an ops on call and a dev on call.
And then what about the ops team?
They're also on call.
Okay.
No, the dev deploys it to production. It's either automated or the dev is the one who goes to Jenkins and says, push the button into production. I think that's what this is about.
Any other questions?
Yeah. No, I think the operation job is getting redefined because it is not getting, it is giving you a lot more flexibility, bigger scale, but it's not becoming simpler, right? I mean, maintaining an OpenStack cloud or private cloud is not easy. So there's a lot of technology and management involved in that. So you're no longer doing at a server level an OS for a particular server. You're doing it at a larger scale from a cloud. So if a server has a problem today in my group, we no longer work with the sysadmin to fix that server. We just destroy that and recreate the server and redeploy the application. So there's only there are very few essays. There's a Unix kernel group. So if you are having a problem that you can't solve, then you can reach out to the kernel group that can help you resolve the problem. But there is no sysadmins that will look at what is the problem with this particular server. The easiest thing is to just destroy that VM and recreate and run the CI pipeline again to deploy your application.
You talked about both an ops on call and a dev on call. Do you try to segregate your alerts based on whether if they're infrastructure or if they're purely application related, or do both get paged at the same time, or how does that work?
Both get paged at the same time.
For any alert.
So there is a knock as well in Yahoo. So the knock either pages them or the system pages them.
I'm sorry, one other question. What about for larger outages if you have some sort of larger network partition or something like that where tons and tons of teams would potentially be involved with that? You expect that all of the ops all of the devs? I mean, everybody kind of jumps in the same.
So
chat
every
room,
team
or-
has their own on-call schedule. So NetOps will have their own call, and SecOps will have their own call. But the NOC coordinates. Okay, if I'm an ops guy, and I say, hey, I don't see any problems with my server, for example. Suppose there is a external user, or they found out that nobody can get onto Yahoo Mail, right? So the ops is, all of our monitoring at the server level is working fine. Then the NOC would call the network operations person on call and get on. So there are incidents where there are like 30 people on the IRC looking at the problem.
Any other questions? All right. Well, that concludes our DevOps meetup for future state of operations. So we just wanted to say thank you for coming out tonight. We really appreciate it.